Right, hello everyone, welcome to another stream. How are we doing? Welcome. Hey there, Ransel. Hey there, Bassandro. How are you guys? So, last stream kind of got cancelled last minute because there were some hospital things to do. Yeah, we're gonna pick up right where we left off from the stream before. So, we got stuck on a problem end of last stream. So this gamepad, right? We were working on this today, but we couldn't get the accelerometer data without root. And there are ways around that, but it requires modifying the system settings. And I was thinking, how can SDL work without getting without requiring root? And the answer is pretty insane, which we'll get into today. The last stream we got the multiple keyboard and stuff working, and then we did a bit of research into how this how to get started on this gamepad thing, right? So yeah, so we got multi-keyboard working and multi-mouse. This is a thunderstorm, your Wi-Fi died. No. Damn. Hopefully it comes back up. But yeah, so here's the answer. How does SDL not like... So, okay. Let's dig into it, give a little bit more visual feedback. So if we run our... If we go into our test thing, run our test program, right? evdev, wait, what we're looking for? Event probably 19 or something. Is this the PS5? Yeah, this is it. This is the joystick. So if we cat slash dev slash input event 19, we get, all the events are in here. So we do button presses and get all these guys, right? Well, this is not really a good enough thing. You can run it through EV test and you can get it actually parsed up. So you see I'm pressing the down key and it responds and gives us all these events. But I was having a problem end of last stream when I was doing the research. So if we look at event 20, which is used to read the accelerometer, right? Yeah, accelerometer and the gyro, okay? So we try and read 20, what happens? Permission denied. So you need to use root, or you need to be part of the input group. So this is something we discovered last stream. Oh no, sorry, one of the previous streams. But I didn't want to go this route because it requires a user to use a gamepad. They have to modify their system settings. But I've had more thought, and this is probably the route we actually need to go because there is a way around this, but it is really crazy. So if I were to now run, for instance, sudo as an example, this gets past the restriction. You can see the accelerometer data being in here, basically. Yeah. So how does SDL go around this problem, right? SDL doesn't need root, and SDL allows you to use a PS5 controller and get all this information. Well, there's another way to read data from the controller, and you can read the USB packets directly. And that is done using this thing called HID raw. So it's HID raw. There is yeah. So basically, on every USB device, I think, I'm pretty sure, you can read back this HID raw thing and get back the raw packet. Hey there, prayer boy. How's it going? What up? Good man. Good, good, good. How you been? Got a Pepsi. Oh yeah. My goodness, splashed everywhere. Good man. How are you? Yeah, not bad, not bad. I had to do a last minute. I cancelled the previous stream. Um, because cheers. Because my wife was experiencing lots of headaches, and she needed to go to the, well, she wanted to go to the hospital. Because they were just too consistent. So we took her up to the hospital. Um, and then we waited. Like it felt like we were gonna be waiting for like an hour or two at most. Then we waited 45 minutes. We get in there and see um, a nurse. I don't know, a person. I'm not sure of their title. And then she does the initial tests. It takes about 20 minutes, and then she doesn't say a word to us. Walks out. Half an hour later, she comes back and pulls in two more patient or pulls in another patient, sees them for half an hour, goes out again, comes back in like 20 minutes or whatever, pulls in another set of patients, sees those guys, and we're just sitting there trying to be polite. And we're getting the service for free, and they're just trying to maybe squeeze us in and everything like this. And then like it gets to 8 o'clock when they start doing the rotating for the night staff, and then turns out we was waiting for like a doctor to come by, and they didn't tell us anything, and then the doctor and then the doctor still doesn't come, and turns out they were doing the rotation, and we waited another. Honestly, I was in the hospital for like 4 hours or more, maybe. I think from the time I left the house, it was like 5 hours until I got back home again. So yeah, it was quite a yeah, it was quite draining really because we didn't even get the answer because we just left. Um, because we were just waiting for far too long. And then my wife went up yesterday again, and then she stayed overnight, and they checked her blood pressure. But yeah, she's doing good though. She's not doing bad enough for them to make any decisions on doing or on taking the baby out or anything like this, or not on any medication. So she's just experiencing headaches, so which is really not great. So I hope. Yeah, so we've just been sorting out her diet basically, and making sure she's not eating anything she shouldn't or drinking anything she shouldn't do. Being careful on that one. Yeah, she's pregnant. Yeah, she's right at the end of it as well. The due date is in 3 days. Uh, hey Basandro, I'm making a GUI for one of my utilities and decided to go with Luigi. It's so nice. Sweet. Nice. Yeah, that's the one we by next. Nice. Cool, I'm glad it's. Yeah, I need to take a look into that and his blog post that he did, right? This one. Because I want to just get because retain my duos, I've used them, my first two jobs and they were really crap and really annoying. But maybe this gives me a different opinion about it and different perspective, right? So I'll link that in the chat if people are interested. How to build your own UI, and it's based maybe the person who made that Luigi library that Cassandra is talking about. I'm the guy who makes the the GDB front end we use for debugging. In a supernatural TV series, there was an episode about how one demon became Satan, revamped hell, removes it on. He removed all the boiling, burning things and left one endless corridor with a line. Oh no. Standing in line, yeah. Awesome, good stuff, yeah, yeah. Maybe some cake would help. Cake fixes a lot of things. Yeah, I think cake's not bad for high blood pressure, isn't it? It's fine. Cake will be good. We should buy more cake. Just can't eat too many too much salt, you know, that sort of stuff. Right. Yeah, so how SDL gets around this, right? That's what I was talking about. Oh my days. Right, let's switching this light. So for those who weren't here, just tuning in, we was figuring out, right, end of last stream, why can't we cat the event file, which gives us the events for the accelerometer and gyro, but we can do it for the buttons? And the answer is, so event 19 is the one with the buttons. This, for some reason, right, has different permissions, right? And wait, which one is it? Oh yeah, and then 20 has, yeah, there's different permissions. But see, they're part of the input group. So if the user's part of the input group, they can have access to it, right? Read-write access to it. So if we run EV test to read the file descriptor on 19, you'll see we get these button presses, and we can just read back these and in our application and make some events for these, right? Even the analogs. But the gyros, not so much, because the permissions are a bit screwed. So the question was, right, is how does SDL get around this? So what is evdev? So evdev is like it's the sort of the generic interface for input events that the kernel, that's in the kernel, is it? Something like that? I'm not quite sure. Yeah, wait. There is some kernel integration with it. Yeah, I think it's in the kernel. So there's drivers for these guys in the kernel that read off the USB, read in the USB packets, and turn that into the appropriate like evdev events, right? So, and you can read those back through the file descriptors. So how does SDL get around this? Well, SDL becomes its own kernel by using HID raw and reads the raw packets in user space, right? So they use this library, this HID API library, which is made by the libUSB folks, I think, or it's in the libUSB project. And wait. HID API. Yeah. So they include this HID API project. So it's made by the libUSB folks. And under the hood, this just uses udev, and uses udev to find the USB devices and the things like this. But it looks for the HID raw stuff. And HID raw is another file descriptor which you can read to read the raw packets from the controller. So we look for HID raw 4. What's that one? Look for a HID raw. Which one is the Sony one? Should be a Sony one dotted about. There you go, HID raw 4. So I think we'll be able to cat this. Dev. There you go. So this is apparently the packet information coming from the controller. So they probably just read that back, and they can process the packets in userland. Yeah, the interface to the kernel to userland within. Yes, interface to the of the kernel to userland within the kernel. Yeah, so that's the way that we. Yeah, so they expose like the file interface, isn't it? So a file is like that bridge between kernel and userland. It's pretty cool. I do like the design. So HID API is a cross-platform abstraction to do HID stuff. This on Linux uses evdev, which we already use, but they search for this hid raw thing. And if you search for hid API PS5, you get to see some source code. And basically, right, there's a good 1,500 lines of code to read back the packets and process that into SDL events, right? So if you think about this, for every single controller that you want to add sort of like proper good support for, you got to have like one of these files, right? So SDL only has these guys, and you read the packets off and you process the packets, and then you obviously turn that into proper events. So, but this solution is very, I guess it can be cross-platform if everything communicate, if you can get access to the USB hid raw stuff. But it's a lot of work, and all that's blocking us is because basically a distro isn't set up properly. I guess I'll make that claim. So what do I mean if a distro is not set up properly? Well, remember when I said this? You're not part of the input group. I guess this is for like if you have multiple people logged on to a system or whatever. But the user should really be part of this input group thing. And then if we're just part of this input group without sudo, we can get access to these files. And we'll be able to read the accelerometer data off of these and the keyboard and mouse. And this would solve the problem of what we're currently doing, right? Currently, we're going, this is my blockchain drawing. Look at it, isn't it amazing? So currently we're going, so this is the kernel with a K, kicks with a K. So it will get read the events through those evdev file descriptors, right? It will write out to those evdev file descriptor things, and then it will in turn get read by X11, right? And then our application goes, I want to read those events off of you, right? This is our game. But there's probably some form of latency added here because we are not going directly to our game. And, we're using X input 2 to do this, right? To do this one to that one, we're doing X input 2. So if we add our user to the, if the user gets added to the input group, then we can skip going to X11 for any raw key events, for the keyboard and for the mouse as well. Obviously, we'll still take these, like where the cursor has been moved through X11, but not reading directly from the USB devices. We'll use evdev for that, right? So this is going to add a benefit, and we should have less latency when we receive mouse inputs and keyboard inputs from the kernel, right? It won't get buffered through X11 basically and go through that system. So that should be good. So I'm looking forward to making this change. Is she expecting your first child? Yep. So we've got our first child on the way. It's going to be a boy. So yeah, it's going to be exciting stuff. Hey there, Raymond. How you doing? How many children you got, Overster? And also, welcome. I'm off for a fruit shop. Then gonna make some tea. Awesome, Perry. Enjoy the shop. Make sure you snap out. Sorry. Make sure you store up on all those lovely snacks. Gotta get enough snacks for the to last the weekend. Oh, so you're doing super latency input. Sounds exciting. Yeah, so we wasn't initially going to do this, but it's opened up that. Yeah, we could go even less latency, I guess, by reading it directly from the USB. Well, it's not even directly from the USB. It'll be the same thing as evdev, to be honest, maybe. But yeah, we're not going through the X11 server for raw key events. Thanks, not so red. Appreciate it. How's things going with you? Do you want to go to food shop for me? No, I got enough snacks. Sorry, Perry. Yeah, it does help translate the key variants, but but we don't use that anyway. Yeah. We use it. We use X11 to get the lookup table data. Um, yes, we use when we initialize X11, we get the keyboard mapping and we map. We get a lookup table to map the scan code to the layout and stuff like this. But we don't. Yeah. Input latency has been such a opaque topic for me. No matter what I try, I can't get as low as Nintendo Switch games. Have it on my laptop. Yeah, I'm not sure. I've not really tried to like benchmark any of this, but this is theoretically better. So maybe you might be able to give this a go, and you can get around engines or whatever platform layers you're using, because you just read directly from these files in dev input and read from the event ones, right? But it does take a bit to get set up though, because I've had to use udev to locate these guys, and when you plug them and unplug them, it's been a bit of rocket science. But we've got there now. I'm doing fine, I guess. How's the project? I saw you struggling with input stuff on Discord. Yeah, we've just been trying to figure out best ways of doing input, because there's no it's quite hard to find this information online, and we've just been trying out tons of things. But I've figured out how I want to do this gamepad stuff, so we're starting on the gamepad stuff today. Awesome, welcome back, Ransel. Keyboard mapping, that's the words I was looking for. Yeah, it's definitely handy for that stuff. And when you want to translate from a key press into some UTF-8 character, X11's great for that. Thanks for sharing the modded GPU thing. I've been looking part. Yeah, watching at that. Yeah, I watched the whole thing. Like the first like so many episodes are pretty good, and it's still quite good up to about 10 episodes. It's got lots of good information in it. Because they talk about actual GPUs and like desktop ones and mobile, so that's good. I said the word actual GPUs. It's really impressive though how the ARM stuff works, right? Like 5 watts. Like it's just good piece of engineering. What they achieved down there in the mobile space. Right, so we're not doing it the super hardcore way of reading back the raw packets. So what I want to start off first is I want to go into. So we didn't actually test anything to do with the wait, what was it? The hide the cursor and show the cursor. Remember we added that API? Remember that? It was like virtual cursor, hide and show. We didn't test that out, did we? So let's see if I can make my mouse disappear and it maybe disappears for the rest of the stream. It'll be funny, right? Right? Maybe not. Maybe should we save testing this till the end of the stream? Because it could go wrong. Yeah. Right, okay, we've got to remember this. So the first thing I want to do then is check to see if the user is part of the input group on Linux, right? So, and if they're not part of the input group, we're going to show a message box and say, hey, you need to be part of the input group. So how do we check? Linux check if user is in group. Can we do it in C without a system, like doing it with a function call? That's like pretty easy. Oh my days. Update, I found how to do it. Scroll. Even though it's ugly, I suggest you'll take this code, fix it, it works. This is like too much work. We can just probably call Why are things not easy? It's nice how they clearly said how the geometry is stored in tiling GPUs, yeah. Yep. Yeah, if those who don't understand what we're talking about, other weekend I found a resource. Someone was complaining that um that I'm just saying a bunch of things and they can't find the information of all the things I'm saying. So I found a nice video which literally has a lot of information about how GPUs work. And it's mobile GPUs as well as desktop. So yeah. Um, yeah, check out the video, it's really good. Or videos. Really good. Well, as I recall, the first two modules about the series is about GPUs and the third module is about ARM Studio. Yeah, the ARM Mobile Studio ones, that's not really, it is kind of handy to see how the tools work, but the sets of videos for the rest of it are really about the GPUs are all good. Yeah, take this code and fix it on good things. Yeah, like someone to understand how they their code is probably more complicated than it needed to be based on how they right. So there's a get group list for a user. Ta-da! This thing seems a lot easier, right? You can just get all the group IDs, and then you just need to know what is the ID of your group, and then that should work. I don't want to worry about how do you expose the workgroup memory in HCC? Did you choose equivalent for compiling? I forgot what we did now. There's docs. So there's static and thread local, but I don't know if we added another one because I did it one way, then I did it a different way, but then I kind of went back a little bit and did an in-between thing. So I think I changed it. So I have to have a look exactly on what past me decided with a few iterations. Intrinsics maybe. Global variables. Right, this describes it all. Yeah, so we added another one. We kept static, but it must be const. Because if it's not const, okay. Thread local maps to. So basically, static is secretly thread local, because the thread local one allows you to initialize the memory with an initializer in SPIR-V. So we call, I think this is known as like an invocation lifetime in for the variable, the global variable. So this one is technically the same, but we make it const, so it's a bit of a hack. But then for doing, you're saying the work group memory, we'd call it dispatch group in our thing. Yeah, so we have a specific built-in storage specifier for the variable, and we call it dispatch group, because it is technically different. But the memory is also uninitialized, which is different to how the C model works. The C's model is typically zero initialized. So yeah. So thread local is private. Good question. Yeah, I think so. I have to double check that. That's in spivv.c. We can easily find that. Spivv.c. Spivv.c. When GitHub wants to work. I could have just looked at my local desktop. Private, yeah. There you go. Thread, yeah, private. That's right. I don't emulate anything about dispatch groups. What do you mean have the same semantics? They don't have the same semantics. It's in it's uninitialized memory, so it doesn't have the same C semantics. Like that's the point of the reason why I did a different. I didn't try to hide it, but behind an existing C thing when it wants to work. It doesn't behave in C at all. Sorry, in a regular C compiler, this won't work because this is a special keyword. Well, it maps to a special keyword. Yeah, it would be an error. Well, yeah, it would be an error. You should, yeah. Because this is global memory that's uninitialized, and its lifetime is like across. Yeah, it's weird. Yeah, it's across. Yeah, work groups, isn't it, or dispatch groups? So that's the reason why I made something separate, because I wanted to try and use the built-in language stuff as much as possible. But yeah, that's what I landed on. Right, so we should be able to get the group, and then we'll be able to make a warning, or not a warning, and a hard error. Scans the group database, C group, up to n groups of the array. Can we pass in a null pointer here and get it to give us the size? Can we get the number of groups? Oh, sample code. Num groups. Joys. Is a value result argument. On return, it will always contain the number of groups found for user, including group. Right, I've got to read this properly. So function scans group database, C group, which will contain a list of groups the user belongs to. Up to dereference n groups are returned in the array of groups. If it was among the groups defined for the user in the group, if it was not among the groups defined for user in the group database, the group, this one that you pass in, is included in the list of groups returned by. Right. Typically, this argument is specified as the group ID from the password record for user. I'm not sure what that means. But yeah, so basically we'll always put group in the list. Always. Always return the number of groups for user, including the group that you passed in. The value is greater. See, it says that it returns, so it's like an in-out variable. So, and this also describes the size of the buffer. So maybe you can call it twice. You know, a bit like the Vulkan thing where you call it with a null pointer and it will just fill in the size or something. Return 0, n groups equal 3. Yeah, so they've called it with a 0 here and then it returned -1. So it returns. Okay, good. Yeah, we'll just call it twice. We can do that. So what's the default group that they use? Is there like a default group? They do a get pwnam. That's for the user, isn't it? Okay. So we do this for the user. So we need to get the current user, do this function. Right, so when they boot up the OS on Linux, no worries very much, no problem. Anytime. So when we boot up the back end, we want to. So here's where we boot up XKB. For those who are wondering, we use XKB to get the keyboard mapping. Yeah, so we use that. This X-Input2 stuff could go after today if we figure out this thing, which would be good. So I want to, before they boot up anything really, let's do the check. We'll get the segfault handler in there actually, we'll do that first. Then check or like ensure that the user is part of the input group, so we can access the evdev file descriptors. We had without root. This has to be, we do it, otherwise we cannot read back accelerometer data from controllers without implementing without reading back raw USB packets for each gamepad and writing kernel code in user space. That'd be quite a lot of effort, wouldn't it? So we're going to try and avoid that approach. So what I want to do is use that new function we've discovered. So we want to get the current user. So I think it's called get PID. No, get UI. Get PID is the process ID. But I think there's, oh, not PayPal. Get out of PayPal. Get out of there. Get PID. Oh, yeah, PID is process ID. So I think you do UID. Yes. Get the user identity. So this guy, can it return something invalid? Always successful, never modify error no. Amazing. There's always a user. I don't know what EUID does, but Unix v6, get UID returned, EUID, shift left, UID, introduce separate calls. I have no idea what that means, but I think the get UID is the right one. So here's our UID user ID. Ta-da! Now, we want to use some of that code that we've been looking at, this get list group. We also want to get the group from a string, or like the input group or something. We got to figure that one out. But let's just get the group list and we'll just print that out. And you get to see all my secret sauce on my system, I guess. So first of all, we want to call this guy and get some PW, wherever PW is. password. Right, so then use PW. Right, I have no idea what this is. So for PW, this is the I guess you're always part of the this pass WD group, so you can use that to change your password or something. I don't know. So this is you pass in your user ID. Right, skip these two includes. Right, that's good. PWD. Oh, pass. Good. Oh. It wants a string. Right, there's one with an I from a user ID instead. Retrieve the user database entry. Okay. Oh, wrong one. Why do people hate CPP? I don't know. Have you ever used CPP? Nice. Yeah. I don't know. Like, there's a lot of overcomplications with C++, right? Usually Rust these days. Yeah, I know some people like the simple things, you know. C++ is yeah, it's quite complicated. And you also have to make sure you're not tempted to use all of the gizmos and gadgets that are in there, you know, because it gets quite dangerous. Yeah, it is very overcomplicated programming in general, right? But every time I use C++, I'm like, you know what? This is the perfect time for some template global variable with an inherited class of you know, all of this lot, and you just start going all in and using all that stuff, and when you don't really need it, and then like before you know it, you've used templates, and then templates need more templates to solve the template problems, and then you're just yeah, you're really deep in a situation, you know. So personally, I think I just try and avoid C++ because it just makes me do dangerous things. I cannot be trusted with those tools. And I don't like the move semantics. Okay. Yeah. Um, um, right. So we should be able to do a thing. So we get this thing called a PDGID. So that can help us. This better not be a string. It is a string. Oh, is there a non-string version? I want to get group list pro version, you know. You can get the list, you can get the string name of the user, right? Ugh. Right. Get in the header file, let's find it. Right, so say get group list. Gotcha. So can't I... Why do I need a string version everywhere? Fine. We'll use a string. We'll play ball. So to play ball, we need to get. Let's find where this one is. Right, where's my Conchar stars? Oh, I love when they take the name unlink. You know. Ah. Oh. Right, there's a lot of stuff in it. So we're basically gonna get like the user. Right, Linux get C get user string. Get the string, the username. Oh. It's in that structure we've already got. Thank you for finding this resource. Oh my days. Because we've already done this anyway. Yeah, and they're going to stick that pointer in the register like a good C programmer. I've never used the register keyword. I'm not old enough for that. If only I could add one thing to C, it would be sum types. So you mean... Oh, too much functional programming. So you mean tagged unions, right? Is that what you mean, tagged unions? Copy me as a hey there, Don, how you doing? Hey there, Soulphone. Yeah, every time I think functional program makes my brain hurt. Ah, oh, tagged unions. Ugh. The name of the user. Right, so I guess every user gets its own group. I'm not sure about that. Don't quote me. So I reckon, can I pass in a null pointer here? Maybe that's a bit dangerous. And then I'm passing, I guess it's always an int, right? End groups. Okay, we're gonna do groups count. Let's break the law. And then, so this should get us the number of groups, right? It should be it is going to be -1. Now, the beauty of this is, now I've got the number of groups. And then we can call it again. After, we do a lovely temporary allocator. Oh yeah. So we get our, is it called our temp allocator? Frame allocator, that's the one. Frame lifetime allocator. It gets refreshed, cleared out every frame. Doing good, pal. Good to hear, Yeah, not doing bad. I've been, we just got the wife back from the hospital because she was being monitored for high blood pressure. But she's doing good. We've been trying to get help for someone to see about her headache she's experiencing because she's like 3 days. In 3 days, that's when the due date is. But yeah, no luck there, unfortunately. Just tagged unions, sneak him in there into the standard. Ugh. Did tagged unions really solve every problem? I don't understand. Like, it's just a tag. Like, it's just an enum. Just put an enum. Like, we've already got enums. We've already got unions. Tagged unions. I don't understand it. Yeah, you always tag the unions anyway. Like when you're programming in C, you don't just go ip dip do and then pick a union field. You know, there's there is thought behind it, you know? And it sometimes got me out of luck mode. Hey, oh. uh, Ever try referencing the Master and C pointers book to help solve this problem? Good point. You know, just pick a random page, select. Some of the wording in that book is like, what are you trying to say? Like, you know, it feels like they've not done any of their research and they're just pulling things out of their head, you know? It's just strange. Well, right, so I think we can get the list. So let's do an exit at the bottom because we like to finish early. Where's Perry when you need him? So if it's equal to -1, I don't know what to say. Why would it ever be equal to -1? If the user has more groups than that, okay, yes. So this will never return -1 because we would have allocated it anyway. And then we should be able to go over the list. Yeah, so we want to temp allocate an array of GID, right? We love a good GID. Groups, core alloc array of GIDT. And then we want to use the frame allocator, our temporary allocator. And we want to allocate groups count worth of those guys. Put that into groups, please. Bam, now we've got a group list. So should we call a function which can get a string for those groups and we can see what group I'm part of, right? So the thing we want to see is like C get group group string. GIDT string. We love a group. What a group. What do we get group? Get group. Okay. ID. Yeah, got it. This guy. Oh, right in the register. It's going in the register, Don. Look at me go. Oh. Right in that register. Flexible arrays are where it's at. Struct foo, in ID, payload. Oh yeah. You get the alignment as well on that data. It's good. Hmm. Yeah, shaders have the same thing, isn't it? The storage buffers. Yeah, the storage buffers in GLSL. They're even in SpearV as well. And the HLSL. Yeah, HLSL structure buffer maps to a a storage buffer with one field, which is the flexible array member. Yeah. Oh my days. And that's what HCC does as well with its things. Right, so we should be able to do a for loop over all of these guys. Index 0 groups count. Right, why have I got it in a register? No one knows. It doesn't even work probably. Damn in. Really, I should call that group IDs, but we'll rename that in a minute. We're just trying to get stuff to work. So we're just going to say like, we're just going to list a number of groups, right? So we're just going to say string, new line, G, name. Right. So then we're going to say user thingy has groups or is in these groups. And this is going to be our test. So pw name. Rightio. Let's give that a go. So I'm going to give it a run. Too many things. There we go. All my secret sauce. So my user is part of the HE rows user group, the wheel group LP sys network power libvirt t. So that's good. We want to be part of the input group. I want to make sure they're part of the input group so we can have access to those evdev things. So we just need to find a way of getting a group from a string. So let's find that gets you a group from a name. We want a GID. Right, so you can find the group structure from a name and get the ID from there. It's probably the way to do it. Yeah, because that's the way the user one works, didn't it? Remember? The user one, to get the user's name as a string, you have to use the... Oh, you don't have to use the string. Oh yeah, no, you could do it, okay. So now we want to get the group that we're looking for. All these registers. Okay. Right. So this is our input group. And voila. So I guess this can return null. I don't know, it's man it. Get granam. Man get granam. Return value is... Oh no, does it allocate memory? Oh, did not pass it to free. Good. Returns null. If not found or error. Perfect. So chorus see if it doesn't have an input group, then I think we're a bit lost. Input user group not found. No, Don, it's not. It's not a casting coincidence, right? This also helps you with alignment, doesn't it? So it helps align your type, right? So you don't have to work out the padding. It's got it's a slight convenience, I guess. So let's go to Godbolt. You get the extra padding, right? So if you do like a strut test, so say if you have like a byte, and you go like, here's your tag, remarch. So if I say int, here's my data, and it's my runtime flexible array member. Size of test is actually going to be there's a chi for your types. Oh yeah, balanced chi. This man's chi is off the charts. So yeah, the beauty of it is, where's the beauty? Give me the beauty. Four, right? So the beauty is this, there's hidden alignment in here. Whereas if you took that out, it would just be one, right? So this is part of the magic about it, is you don't have to, when you do size of this, you're actually getting the size of this header, including the padding in it, to get you to the actual data, and then you just say plus this amount of data I have. So it's quite handy. Yeah. So it's more, it's a bit more than convenience about casting is all. Yeah, it's pretty cool. Yeah. There's so many more better features they could have added instead of that feature though. But yeah. Okay, so we get the group. So we got the group ID. So we want to get the group ID. So GIDT, and this is going to be from input group dereference group ID. Ta-da. So these are actually group IDs. And then we just want to go over all of these. And we want to say, hey, if input group ID equal that, then we break and set something to true. So we are saying bool found input group. Then we're going to assert. You know what? We shouldn't really assert. We should do a nice little message box. We haven't got a message box abstraction yet, but we'll put one in quick because I've got one in the HCC code base. So we're going to grab that. Hey, Kraz. Yeah, I could do it that way. But then that's like, yeah, but then I'm putting it in the code where it actually does the, yeah. Like the idea is the check only goes at initialization time. Yeah, and then I'm not doing it. I'm doing it when they boot up the application and not when the application's already running, you know? No, it's just a little macro. It's just that, basically. That's all it is. Yeah, just to save typing out a for loop every time. I could just copy paste it. But yeah. Yeah, so if they've not found the group, I think we'll do a show message box. So we'll get the message box API from the HCC project. There's in the sample project. There is an OS abstraction. So platform Linux message box, perfect. So we want to just drop that somewhere. Let's make a new section. It's just a one function thing, you know. So I guess we could just put it down here. OS message box. I spent good time getting this message box system to be quite cross-platform. So we want to basically have something like this. So we'll just copy and paste it over. We'll go over what it does, right? Or how it's implemented on each platform. On Windows, it's dead simple. On Linux, there's a few different options, and a user might not have any of these, and then we're just, you know, buggered really. But maybe we could print it out to the terminal. But yeah, I don't know. Let's drop it down here. Right. So how does it work? So basically, we get the command here. Why is it limited to 1024? That's not good. We should probably do some form of temporary string allocation thing for this. I do have in core, we have got a HCC string, core string, which is just a size string. It's always null terminated, but it's just but we have a nice way that does the formatting thing for us, and it will allocate a string and everything. So we just want a temporary live string. So where's that frame allocator? We'll get that. Chuck that there. So we only do it for a few things actually. So we want to put their sort of message in a string. That'll be equal to core string format v. Used to use the frame allocator. So it wants to go here, right? Frame allocator format vargs, something like that, I think. Yes, that's just going to allocate a string and use the format stuff. So it uses snprintf to get the size, and then it uses snprintf again to actually copy it into the buffer. If you pass in null and 0 at the start, it will give you back the size of what the string is you need to allocate, and then you allocate it and you run the same command again. So that's how the format thing works. And then we basically want to run the actual command. We'll do another allocation. So you want to print into frame allocator. Oh yeah. Then what was in buff apparently, but that's just message now, isn't it? Message dot data. Not the V version. Nice. Right, then if we don't have a message box, we'll just print out standard out. Message.data. And and then we run the command. If there is a command. Good point. Oh no, that will return. Cool. So basically there's a few different things you can use to display a message box. So obviously, like, you could open up a new window and then do all this code yourself. But when you run this command, it will stay here and it won't return until the message box is closed. So it's a report an error when the message, and when it closes, it will give it back to the application. So yeah, we could do all this sort of stuff in our application and do a whole render to another window, but it's just a lot of work and it's just easier to use these. Hey there, that guy, Drew. Hey, thank you. How's the strut programming? I'm not sure what you mean by strut programming. Do you wanna? Is there extension in C which allows to have a function that will return a macro, which can be translated into a structure? I'm looking for a way to generate a type needed inline without calling a macro before use. A macro is, preprocessor. I want the macro to run in the function prototype as well. I'm not sure what that means. Why didn't I ask you not to let him never near a keyboard again? Why? Why are you enabling him? I thought we had an agreement. Yeah. Sounds pretty sketchy. Hey there, Meeple1, how are you doing? Egotist, good to see ya. Good to see ya. How you been? We are avoiding writing a userland driver for the PS5 by... Yeah, that's what we're doing. We're avoiding writing a userland driver for the PS5 USB like SDL does. I'm not sure if you guys know that, but SDL, it parses the USB packets directly from the controller. Like a crazy thing. 1,500 lines of code. That's what it does. Insane. Cool. So there's one called Zenity, and the way this is all written, it handles new lines and everything in the box. We've tested it all out and got it to work. GX message on GNOME, X message if you've just got the built-in thing, and then notify send, which is another one. Maybe these ones should go up, we'll see. But anyway, maybe the priority should change, but this is good enough. And then on Windows, we can do a bit of Windows programming, don't worry. I've got the Windows side covered. Then on Windows, right, there's a message box thing here. It's dead simple, it's message box A. It doesn't get simpler than that, you know? So we still need that same bit of code. This one, I think. So we can support any size message box string and without stack allocation as well. Yeah, and then we call message box A, which will do the message box for us right on Windows. And that's what's great about Windows. You don't have 50 versions of this message box thing. But anyway, Linux. So back to what I was doing. Now we've got this user group thing. So backend initialize. So yeah, if the user's not part of the group, give them a nice little message, and we say, right, user, your user this is not part of the input group. New line. We need this to give you super fast raw input, or to have access to raw input events to give you super fast, awesome super fast and awesome experience. There we go. Run this command in your terminal, user. To add your user to the input group. And you know, this is on Linux. Everyone on Linux knows how to flop open the terminal and get stuff done. So we need to, right, closing all this garbage. Too much to give yous. Okay. Give. There's only 2 gives. Your user is not part of the input user group. We need this to give you oh yeah, there is 2 gives, isn't there? We need this to give you access to get access. We need this to get access to the raw input events from the OS to give you super fast, to give you a super fast and awesome experience. Run this command in run this command in your terminal to add your user to the input group. So pw name, and then we want to actually put in the command, and that command is it's as simple as message box until you want a proper notification. Is it really? Oh, so if you want like a one that shows up in the notification tray, it's like rocket science, is it? I didn't know that. Yeah, just egotist. If you literally search for HID API PS5, you'll find in SDL they've got 1,500 lines of code for literally reading the raw packets in. So it's probably a super great experience in terms of like latency wise. I don't know, it might not be too much better than using evdev in all honesty, but it's definitely better than going through X11 from. But yeah, that's the thing. They're not doing it for latency. They're doing it so they don't have to do this, right? Make the user join a group. I'm pretty sure, because in SDL they go through X11 to get their keyboard and mouse events, and we're going to avoid doing that now because we're doing it this way. So I think, yeah. So I've not tested it out, but we should get less latency. Yeah, because it's not going through. We won't be going. X11 reads from evdev, does some stuff like to process it, and then will send it through its file descriptor for you to pick up. So instead, we'll be reading directly from the evdev file descriptor and reading it ourselves, right? So reading the events ourselves. So hopefully we get better latency there. But yeah, we'll still be reading the X11 events, so we can tell where the OS cursor is, right? But we just won't be reading it for raw inputs like the raw relative mouse positions and keyboard presses. But we'll still be using X11 for the translation between the keyboard layouts. Who am I ignoring? Smoother controls. Yeah, look at that. I'm having difficulty following the instructions for the LR parser. Is that nobody has clear instructions. Even the example I see is the same. Is the same in everyone else's text. I've forgotten what LR parser is. Is that the new style of parsers? Did I miss the core frame allocator in the Windows? Ah, good catch there, Ransel. Good catch. Look at that catch. Ransel is the compiler. Yeah, recursive descent for the win. You get the long jump, you know? Long jump is amazing. Provides access to raw input events for smoother controls. English. We need this comma to access. Yeah, why have I done that? Right, so the new suggestion is this provides access to raw input events for smoother controls That's much shorter and more elegant to fit in a message box. Thank you. I forgot an S. Thank you. Right, so we need to find the command. And I'm obviously things. Now it's ChatGPT to reformulate in a professional way. ChatGPT. The button up LR parsing, I see. Yeah, that's the new fancy way where you can say at this cursor and do all that. Insane. Good luck. To enable raw input on Windows, it's like 10 lines if you do it nicely. Yeah, I've been looking at the Windows implementation for some research. I've heard there's some issues with it though, but yeah, I still want to use it though, despite those issues. Once you do that, do try and help me compare it. Once I've done it, help you compare with the raw input. Also help me. It does ballistics. What is that? The shift reduce thingy. With the stack and the I'm not sure what this is. Where is the C source parse code in HTC located? AST gen. That parses the tokens. ASTgen.c. Yeah, source ASTgen.c. So source directory. Oh, you found it. No, you got it. You got it. There you go. By the way, there's a group member function. Damn it. Yes. Wait, there's a group member function. I didn't realize that thing existed. Linux. Oh yeah. Wait, what does this do? Group member. That doesn't say it's not in input group. That's just saying if the group exists, right? Test whether a process is in the group. Excellente. This is what we want. Thank you, Akraz. Man, it probably does something like this under the hood, but like, you know. Even better. Wait. Wait, this is what he's asking about. Oh my days. Without the need for this. Oh, you're talking about declaring it in the... Right, I see what you're saying. Yeah, because you don't want to use an anonymous type. Yeah. Hmm. No, I don't think there's a way. Hmm. Yeah, there's not really too much of a way to declare. You got to declare stuff up front in C, which I don't really find too much of a problem. Right, so we should be able to do this. So it's equal to 0. Returns non-zero if any of the callers matches that, otherwise 0. Yeah, so I think we want non-zero. If any of the caller's supplementary group IDs matches that, yeah. Oh yes, you do want equal 0 in this case. Excellent. Cool. So we should be able to remove a bit of this, right? This stuff, to say the least. We still need to get the PID though. So we can get the strings, but only if we're in here. And this UID only if we're in here. So voila. That's much more simple. Thank you. So now we just need to, there's a code to add a user. So Linux add user to group. It's like user group -G or something, I forgot. The user mod group username with a sudo. user mod dash a input, then whatever the name of your thing is, put another one in. And there you go. So let's give this a go, shall we? Give that a run. Oh. Oh. So it's trying to display the message box, but I think the frame allocator must be allocated. Wait, it might not be because the user... It requires... No, it should be. We do pre-initialize, I think. Source main. Pre-initialize, initialize the allocators, then OS initialize. It should be allocated. So why does it crash? Couple of fins. Oh no. Can't finish, obviously. Clone the arguments. Get the size. So it kind of writes most of it in there. I guess it must mean the pointer I'm providing might be wrong. It's physically putting the S's in there. Oh wait, is it? Yeah, it's put \b in there for some reason. There's something fishy going on with that. pw name. Right, so there's my username. So something fishy is going on, has been passed through is all. No, that's fine. No, it's got to be a positive number. That's fine. Whoa, thank you so much for the support there, meat beer. Meatball one, I guess. Thank you so much, sir, for still supporting me. Thank you, appreciate it. You give me a lot of support. Thank you, sir. Yeah, so you'll be able to get access to the code if you go over to the GitHub. Let's just drop a... Wait, am I not seeing something in the chat? Did I miss something? You're so knowledgeable, I would have to have thought these things. Oh yeah, the parsing tables, I've seen these. When I took a look at like Tree Sitter, the way it generates its parsing tables. Yeah, I don't know. I would have to. I've not looked into this, because I've not wanted to solve this problem basically. But yeah, I don't know much about it. Yeah, this feels very like there's a lot of compiler theory stuff that I've not read into, basically. But yeah, I have no idea what this is like. I've just watched a few videos and heard people talk about it. Oh, it was only a one-time donation. Wow, thank you, sir. Appreciate it, regardless. Thank you so much. Um, Yeah, so we're passing these strings wrong. Like, somehow. They're going in there. Dollar, dollar S, dollar S, dollar S. I'm sorry, dollar percent. I just saw that dollar there. My brain was like, oh, they're all dollars. Um, I do see this thing's uppercase. We'll fix that in a bit. But we just fixed the problem. So, oh, there's a comma there. Can you see that comma? That's sneaky. We want this all to be one string, you see. So I think that's the problem. I think that's the problem. So there's too many arguments being passed in, I think. Lowercase for the win. Right, so there's still a problem. Programming. Seems pretty legit to me. So let's go inside the message box and see if we're doing anything plain dumb. So this thing fails. Am I right by saying that? Wait, which one was it in? It was in this one, wasn't it? So, can we move this up here and see if that fixes it? I doubt it fixes it. It's still this line that fails. It said 9.6. So this one runs fine on the copy. And then it fails on one. Oh, it fails on 120, does it? Huh. Right, now it fails on 120. What have we done? That shouldn't fail. P format. Args copy. Pretty sure that's right. Maybe the args copy. Is it the args copy the wrong way around? Oh, CPP. My favorite. So VA start. Oh, I would mean VSM printf. How didn't I do that? Oh my days. That must have been a... So I must have written that from scratch. From memory and forgot to do the VS in printf. Thank you so much. Oh my days. So for people who don't know, this takes in the variable arguments list. Yeah, and I wasn't part... Instead of... It takes in this instead of the variable arguments, which is like a ... it could be anything, including the VA args. That should have been an error. Compile error maybe, but I guess you can have variable arguments with more variable arguments passed in. But yeah, that'll work now. It just then printed out Zenity into the terminal. Right. But we made progress. Thank you so much. Appreciate it. Anyway. So why did it print out Zenity into the terminal? Let's follow it through in GF. So BOS message box. So you got a message now. Oh, I set epic fail. Hey Avaligo, how you doing? Welcome. Oh yeah. Your user, HUROS, is not part of the input group. This provides access to raw input events for smoother controls. Run this command in your terminal to add this to the user group. User copies this. Wait, we didn't put the super special word, right? What's that special word? Sudo. Close. Super secret password. Now rerun the game. Still doesn't work. Why doesn't it work? Or run new GRP input. Oh my days. So bad. Wait. Huh, that didn't work. I need to relog in, do I? Hey Jim Mega, how you been? Good to see you. So looking into making my logs less terrible. Oh yeah, you got to avoid calling Windows less. Yeah, you got buffer that, you know. And then give Windows a buffer and it'll be like, I can do that. 5 buffers, maybe not. Should I put the ID after doing... You should be in that group after that. Huh. Not quite. Do I not have an input group? Does this show all of the groups? Right, so you want me to run that, then ID. Right, now I'm in the group. Twice. Am I? Let's run groups. Yes, a minute. Sweet, so if I run it now, I still get the problem. But is that only in this session? Yeah, it's only in that session, and I think when I launched the game, there's something about it. Yeah, but I don't think it detects me still. because yeah, I'm in the input group, so something fishy's going on, that's for sure. So we did have code earlier. So let me do the magical, do this. Bring this back. Well, we could run groups, right? But I guess that's how this works. Here's our old code. And we just want to print out get group, get grp or gr. I forget this stuff. Group IDs index name. Let's try that out. Yeah. Oh, I see the input group right there. Can you see it? So I think we might have to go with this method that I went with before then, because this one doesn't want to work. Like when you've just created it or something. But yeah, you should have to log in and log out and log back in maybe, and that'll work. So why doesn't this one work? If the calling process is in group ID. Let's see if this one works. Okay. Okay, it ran and it left fine. It didn't exit with a problem. So if we leave that. Okay, so I'm going to keep this method in just because we know it works, but it's not as elegant though. Yeah, it's strange. But I think though we should tell the user to log in and log back out. Run this command in your terminal. And then log out and back in again. So that's what we'll suggest. Okay. So now we'll keep in this terminal. Right, progress. So now what we can do is we'll have access to the keyboard inputs, the mouse inputs, and the gamepad inputs that we can all read from. So we've already done the work to use evdev to get all this information. So where we poll the events, this is the code that we poll to check hot plugging. So we check if it has an event, and then we do that stuff. But we haven't, but really what we should do is we should iterate over all those input devices. Okay. Oh no. Yeah. So the plan, so I think we'll get rid of xlib eventually. Not xlib, xinput 2 for the keyboard mouse stuff. You know, maybe we could start with a keyboard mouse, but I don't know. Oh, I've said gamepad today. Let's stick to gamepad. So we'll get these in a minute, all done as we go. But yeah, we'll have like one for keyboard, we'll have a branch for mouse and all of that. So we got all these keyboard features and that. So the beauty with this design is an input device could be anything. It could be a keyboard with a mouse, it could be a gamepad with a mouse, you know. So lots of good stuff. Lots of good stuff. So we're just going to read back directly from the evdev file descriptors. Accelerometer and gyro. So I think accelerometer and gyro are kind of in the same boat here. And same with touchpad maybe. Touchpad and mouse maybe. We'll see. It might be different. Maybe you can simulate with SSH. What does that do exactly? 2CX host. I'm not sure what that does. What does that do? But yeah, so we've got that now. So we need to get the backend. So the backend for the input device has all of the device node paths, so we can just read from there. So what we want to do is just simply check if there's something for us to read. Now, I think I remember writing some code before. Let's have a look. Compression and X forwarding and version 2 protocol. Right, how does that solve our problem though? What does that do? Test directory test.c. So we basically have this test program which we use to log out every single device, input device and USB connected. I also had another program in here with I separated with this sort of else if, right, and just enable it. We did one for X input 2 when we tested it out, and we did another one for lib evdev. So you could use this lib evdev thing, but equally we could just it just uses the raw Unix stuff underneath. So I think we might as well use the raw Unix stuff underneath, and just be familiar with that, because this library is just calling it for us. You know, there's no, you know, it's another dependency and, you know, all sorts of stuff. So what we want to do, it logs you into the computer. So you get the group, right? But will it like log me out in any way and affect the stream? Oh, right. So I'll be able to SSH into the same computer. Yeah, but it won't be the same X session running the ID, because there'll be 2 X sessions then, right? Maybe. I forgot. Oh, I got myself a UPS now. I don't need to worry about losing power on my PC anymore. Sweet. Yeah, those are quite rare these days, but still good idea. So you're not in the middle of like losing work or anything. That's good. Up to 1,200 watts. Right, so it should last you an hour, right? Something like that. If your PC or 2 hours, depending on how much I know you got a beefy PC. Yeah, I'm not sure. Yeah, I'm not sure if it's going to provide any. Thanks for the suggestion, though, Almost. I think. Yeah, I think we can just live with for today's stream just being in launching from this at least. But from a user's perspective, they'll just need to log out and log back in because it seems too many hacks on hacks, basically. So when we open up when we get this back end, so we're getting all these strings and stuff like this. So my question is, like, if you open up these file descriptors, yeah, I think we'll keep the strings around. Yes, it does these string copies. So here we want to put in this open mouse, read only, non-blocking, right? So that will go. We'll repeat these. Where you're using name and R. You can also try the get group list approach. Yeah, I just did the get group list approach. Didn't I solve the problem? Oh, so you're saying there's a different function I could have used? Still though, I don't know. Yeah, we'll have a look. We'll have a look. Right, so int file descriptor, file descriptor. So if they become invalid for some reason, then the device will be unplugged anyway, or something like this. Yeah, we'll have to check about that, how this will handle. We're going to change these sizes. So we've increased it by 4 times 6, 24, right? Then right, let's calculate a time. So 20 times 6 plus 24, rounded up to the nearest 8, which is 148. So we need that number to go here. Sweet. So that's going to go into dev node fd for file descriptor. So we're just going to drop these all in here, open all these boys up. They should all open, unless you disconnect the device, in which it would actually disconnect it anyway. But yeah, we should probably think about that. Maybe it should be fine. Touchpad, dev node. Okay, we'll go around again. Keyboard, gamepad, accelerometer. Now the gyro and the accelerometer, I don't know. So for Linux at least, I think these are an OR. We'll open up. There is no gyroscope dev node. It's accelerometer, I think. I don't know, we'll see. I've really got to get more devices. Right, so touchpad, keyboard, gamepad, accelerometer. Okay, excellent. Ooh, so now what we can do is simply read from it in here. Right, so we should, I think there's an example I've seen before. Let's go and fish it out. Linux evdev Gamepad. There's a handmade network post, I think, somewhere. There you go. So something like this. So we want to use, this is it. This is an evdev. Perfect. Yeah, so we want to like read from that thing, get like a packet of input events. 8 input events per frame is pretty extreme, more like 1 or 2. High as 4. Yeah, I don't know about that. How good that is. Maybe we should have more. Just in case, right? It's not it depends how big the structure is. We'll have a look. But if it's very small and you could just store many more on the stack, it's good because this could just crash the. Well, but then again, it's in a for loop anyway, so it's just going to keep going around until you get -1. So reading 8 at a time, at most, isn't really a problem. So I don't know why that comment's really there, because you're reading more than 8 per frame. It's a 2200 VA. It can output at most, right? It's not an hour. It's a 1 minute at power draw is 8. Oh, it's a 1 minute. Oh, wow. Okay, so you can get like 8 minutes on it. So yeah, at least you can save your work, close all those Visual Studios you got open, and jobs are good. Log off. Oh. Yeah, so this is probably good. We want to get this header. All right, let's drop that in. Did I use libevdev in the end? I don't think I did. Because you can just use a. Yo, get rid of that. Oh no, you might need that. No, we don't need this. We'll just call the kernel directly and just do it that way, and not depend on a library. Okay. So, right. There will be one of these guys. Let's just drop this in here. And we'll pick from it. And just have a bit of a scan about what this is. So strut input event, how big is it? That's the question. It's a few longs. I forgot how big that is. Is that a 64? And yeah, so it's 2 64-bit integers basically. Another long. Wait, no. Yeah, so it's about 3 64-bit integers, because this is all just how do you deal with time on the system, right? And then this is just another 64-bit integer, basically. Cool. So it's not too bad having quite a lot of those on the stack. So anyway, we'll stick this up here. These are our events. Then we want to basically do auto. Love me a good auto. Right, so you'll get back the amount of bytes that you've read, I think. It's something like that. Return or 0 for end of file. So you want to basically say like result, I guess. Res is less than or equal to 0. We're going to break, and then we'll do some stuff in here. So we need to get our file descriptor that we're reading from. So this is for the mouse. We can start with the mouse and give it a test, right? Maybe. No, I think we'll do Gamepad. But yeah. Yeah, we'll do Gamepad. So it pings the computer automatically do. Oh no, yeah, save all work and quit. Imagine if you're halfway through an edit or an undo or something. Mean Jean, how you doing? How's it possible to make a game without an engine? That's just not a thing. You sure? Just check glibc code about the mem. It uses getGroup syscall, or getGroup uses NSS database, which is populated with slash. So does your code show no when you're not in the group? Interesting. I'll give that a go. Right, that didn't. Wait a minute. No. So you don't have to log out then. So I do groups. Yeah, I'm not part of input now, so I don't even have to log out and log back in. Yes. So we can remove that thing. Thank you, thank you. But yeah, lean, mean Gene. It's possible. We just not got to overcomplicate things. We've obviously taken a bit of a detour here and done things. I have to log out now? You sure I have to log out? I didn't have to log out, did I? To run the game. Since now I won't be able to open the device. Yeah, but I'm part of the input group, isn't it? Oh, will I? Cat. No. Yeah, we'll have to, wouldn't I? Right, we'll use sudo for a bit, I guess. For this stream. So we do have to log out. Damn it. Wait, but what happens if I do this? Cat dev input. It works. So I'll stay logged into this environment. That'll work. But yeah, it's possible to do Gamepad engine. You just not got to overcomplicate things, and it's very easy to do that. We've kind of started to overcomplicate it by going down and doing Gamepad stuff, but I've never done it before and I wanted to learn it. You know, so it's just one of those. But yeah, yeah. So I had a bit of a detour. Yeah, that's impossible. Ralph Wiggum. Me fail English? That's impossible. Love a good Ralph Wiggum quote. Ah. Yes. Go apple, go orange, go banana. God, I love Simpsons. Me fail English? That's impossible. Good man. Ralph Wiggum. There's so many good quotes from that guy. Gamepad node. File descriptor, get the events while they exist. Sweet. Now we should be able to look at the event. Oh, I love me a good auto. So strut input, let's call it E, right? Address of events, EVI. Right, there's a count apparently. That's the amount of bytes read. Yes, that's correct. So now you just want to do a for loop. Event index 0. Events count. And then, let's just, event index. So we should get our days. We could just do that instead. So you get the type. And there'll be a value as well. EV value, type value. Also a code. So type code value. Okay. Type code value. So u/u/d. E type E code E value. Sweet. So we'll give that a go. We're not gonna, we'll get rid of all this now, I think. But yeah, we'll get rid of it just for a sec, just to test it out. What have we done? Did I not round up my thing right? No idea. Shoot. So 6 of those. And 6 of these. Oh! No. It's fine. 6 times 20. Oh, it's not rounded to the nearest 8, it's rounded to the nearest 4. So it's 44, because it's not char star anymore, it's char array, which is an alignment of 1. So that's 144. Ta-da! Right, let's run our things. Thanks, guy from Mars. Appreciate the compliment. With that username, why do I feel there should be also someone called Girl from Venus? I don't know. Maybe it should be a book. Be a nice sci-fi novel, and then made into a terrible movie. Okay, so now we run the game, pick up the PlayStation controller, and it's starting to do stuff. The analog sticks are very sensitive, so if I press that now, the up, down, you see? So top and bottom is 17, so I can move the mouse over and it's gonna, right, where this cursor is in the middle, there's gonna be 17. If I press up and down, if I press down, it's positive, right? For some reason, down is positive. We'll flip that. Up is negative. Left is negative, and it's 16. Right, so see, we can take these. We got a bunch of zeros going in there. I guess it's null terminated in some way for some reason. But we've even got this trackpad. Oh, okay, that's different. That's not doing anything. But the analog stick does a thing, right? Good. So we're getting things now. It doesn't crash. So what happens if I unplug the device? Wait a minute. Once I unplug it, does it crash? Cool. Didn't crash, but it said disconnected. That's good. Plug it back in. Now I'm gonna start pressing buttons again, and it still works. So that's good. So I'm glad we've made progress on that today. So let's keep that progress going, shall we? So we've got a bit of a problem. I don't think these are standardized. These evdev things. So I think in SDL, I know I did just say SDL has its own little userland driver for this using HID raw, right? So they process the packets and stuff. But they also have an evdev thing, I think, and I think the way they do it, which is kind of an obvious way of how you'd solve it, is if these sort of codes that you get back are not standardized on for a controller, you might want, and so to support more controllers, you want the user to be able to custom map the buttons, basically. So there's so many different codes, right? We'll bring them all back. So I don't think we'll do something like this, because this is not flexible. What is flexible is being able to know. So I think the type stays the same, but the code might not, right? So the type is like ABS key. So ABS will mean for stuff like the analogs, I think. Yes. Whereas key would be for buttons, obviously, and rel is for like mouse relative positions, stuff like that. So we'll see what sort of ones we get. We'll try and see some docs, but then the code is not standardized on, from what I remember. So these could all be, they seem quite. This seems like there is some sane defaults in here, but they could report. Yeah, I don't know. We want to rely on these though, but they could be good, right? You've got LTLR and all of that. So these, but yeah, we'll have a bit of a think. Okay, so is there anything else we're missing from these? But should I press some more things and see what types we get? So I'm just trying to look for any other type when I run it. So I'm going to press these guys at the back. They've got a 3. So you press it all the way down, and then when you release it, it gives you a 1 event. 3 and a 1. We'll remember those. I'm looking at the furthest left column here, right? The type, as it's called, when my cursor is, or was. So we've got 3s are buttons, clearly. So that's key, EV key. This one must be EV key as well, but 1 when you release it, that's an interesting one. We'll look into that. Pressing more. So, okay, no, these are keys. So why the direction all? So these D-pad ones are a 3, which must mean like an analog in some way. It's weird. So these face buttons are 1s. They're probably buttons. Shoulders, the L1 and R1, those are 1s as well, so they're probably buttons. Then these are 3s. These will be 3s, right? Yep. So there's nothing else. Oh, there is these share and whatever buttons. These are obviously. Oh wait, what are these? Oh, the analogs are going. Yeah, these are 1s as well. Okay, so we've only got button and keys. And obviously when you click in the analog sticks, they show up as 1s. Okay. Good to know. So if we bring this back, see ABS is 3, says absolute positions or whatever. I'm just guessing. And then key is a 1. So for a gamepad, we probably just need to look at ABS. Yeah, we probably need a special mapping thing where they can control like exactly what thing it lands on, is it ABS or key. So I think maybe we can put the mapping thing in, but hard code it for now and then do a proper file for it later. I don't want to spend too much more time on this. So we can just keep with the defaults at least. Right, so SDL2, let's see what they do for evdev mapping. So evdev defaults to, sorry, SDL1 maps to evdev. Only supports the new, SDL2 only supports the new evdev interface. Do they talk about the mapping file in here? Remapping gamepad of SDL2 applications. So use the controller config environment variable, which includes the GUID, the name, button / axis mappings on the platform, right? So A on Xbox maps to B1, B5. Right, so they have button and axis. So axis 1, axis 2. That's quite interesting way of solving the problem. So they have like a right, so B1 stands for button for short, so I guess it will map to key, right? And then A is at axis or ABS, right? A is short for axis, and then right, that makes sense because the right. Oh no, where is it? So yeah, the D-pad. Does the H mean then? Okay, maybe I'm not quite following. Yeah, but that's interesting. They have that sort of mapping file. So we could do a similar thing like that, basically. So we will provide our own files or something like that, and if we don't have one, the user can just make their own. We'll get them to be able to remap it, and it'll print out their own, and that will save it out, something like that, and they can send it in. Well, I'm sure Jamega, you'll get to write in the game bit soon. You'll get to a point where you're like, this is usable now, and then you can start like writing game code, and then you'll realize like, oh, this part of the engine needs doing, and then you can go and do that. But don't worry, man, you'll get to it. I'm still doing engine stuff now as well, as you can tell. Bit of a detour here. Hey, Davros. Alternate simple engine plus simple game equal. You will complete it one day, maybe. Hey, Davros, good to see you. Have you seen the engine tech that's been put together by Mr. Avros here, Joe Omega? Have you seen his technology? He shared it on Reddit in the Rust subreddit, is it? And gradually improve each bit. Yeah, that's a good point. Just build a simple foundation. Yeah, extend it as you need it, right? So yeah, I think we want to have like, there'll be like a user's mapping file, right? We're not going to make this mapping file, we'll hard code it, but we'll write this code to assume this mapping file. Sorry, to assume that the mapping file will fill this thing in, right? And this is specific for evdev on Linux. You can't write this mapping file that will map to the Windows one. So this is going to be specifically for Linux. So what we want to do is just write out the default map. So we have in our OS header the Gamepad action. Look at this guy, isn't it beautiful? So you've got all the, every analog stick direction has its own thing. So you can remap completely everything with this one enum. And we'll add more if we need them. So you've got the face buttons, which is like X and that, but we've given more agnostic names. D-pad buttons, start select, and all of that, right? So we've got this, and it's going to look up into some other thing. So what I think we might do is we'll have a Linux source OS Linux thing. So we'll make another structure, and this will be like our. Is it specific for the gamepad? So you want like a. So given this, we want it to go two ways. Yeah, so I think we'll call this like a evdev. So like OS Linux evdev. It's like a button or map. Evdev map. It's not really a map though. It's like a event key. Because map, I use the word map maybe for like, a whole collection of things, which is like a map, like a hash table or something, or like a lookup table. That's what I use the word map for. So this is more of like a type and code. There's key or more of like a, what is it? evdev key or binding. That's it. It's a binding. Maybe that's a bad name. So this will map to. So we've got type and a code, U16s. So U16 type, U16 code. So like this maps to strut input event in Linux input.h. So this is the thing we want to write to a file, so they can map it into this type and code thing. Yeah, so we'll just have an array, and the array should really be, it's a binding array. I guess we can make it static. This is our default bindings. And we'll just do a lookup table for this, but obviously it'll be kind of a reverse lookup table, right? So you got your bindings, and in C you got this lovely thing called a C designated initializer. So anyone had to find the post because the Rust Reddit is quite big. I don't have the link anymore. Do you have the link, Davros? Do you wanna share it? It's pretty decent. It's made some good progress. Oh, PM the link. Awesome. If you want, you can share it here if you fancy. I don't mind. Um, so we're doing a structure in here. So I think you can do this. I'm not sure. Dot type. It might be only C++. So the type is going to be EV ABS. Is ABS 3? Yes. So on the D-pads we've got 3s. I forgot what numbers they were, to be honest, for the code, but we'll look into that. Code will be something else. I don't know. We'll see what that is in a bit. Let's just put 0. So it seems to... Right, that seems to be fine. So I'm going to record a macro where we're going to just make this a lot easier. So we'll just say evabs.code equal 0. Go down, and then we want to just do 21 of those. Nice one. Cool. So we've got to get all these right. So we'll test it out. We can test it out now. We might get an unused. Yeah, let's test it all out now. We can fit all these in properly. So we've got a bunch of 3s and 1s. I think these are all. Wait, ABS. What was the other one? Key. So these are the face buttons. X, Y. Sorry. X, square, triangle, circle, that sort of stuff. These are keys as well as buttons. The stick left, and yeah, when you're pressing the stick down, shoulders, shoulder left, shoulder right. Now these are definitely ABSs, right? These are the analog sticks. And then trigger left. And you'll get in maybe a signed value, so you might have to be like, what sign do I want to pull from that? So we'll look into that. Trigger left, trigger right. Those are ABSs again, I know they are. Okay, that's good. So let's take a look into this. You felt the helicopter flying over. Excellent. Yeah, I remember when I went to Ireland in Dublin, and we stayed in a building, in a hotel next to the airport, and it just airplane came over and just shook the building. So yeah, it was good times. You know, waking up at like 4 a.m. with the airplane just going, waking you up. 2 Chinooks yesterday, I guess. Oh. Okay. So right, let's get getting these default numbers. So here we go. It's doing a whole bunch of stuff. So let's go one by one. So we'll do I've just got the controller here. I've got to lay it flat so the analog sticks don't go crazy. I'm just fiddling with the analog sticks so it's not printing out a bunch of crap. Alright, we're good. So I'm going to press left on the... Oh, it's still going. So left on the D-pad is a 3, 16. Yeah, we need a sign in there as well. 16 and 17 is up and down, 16 is left and right on the D-pad. So these D-pads here is 16 for the left and right. and then 17 for up and down. Bearing in mind, there is a sign we have to deal with. So we need to add a new one which talks about the sign. So you probably need a Boolean. So the thing that you're looking at is like if I'm less than or if I'm greater than. But if it's 0, yeah. All right, I think we'll do a. Yeah, so we kind of want to like a -1. Do you want like a -1? Yeah, I think you may want like a -1 or a +1 or. Yeah, Boolean is positive, I guess. That's what we'll do. So I've got to add that all on the end. Mostly true. Damn it. Right. So I got about 22 of those. Boom. Okay, so left is negative, down is positive for some reason, poor decision on their part, up is negative for some reason, again poor decision. Cool, so we can move on to the next one. So next one is face left up to, so this is all the x square circle, that sort of stuff. So let's do some more mappings. I want to go around x square triangle circle. Alright, I got them all, they're all here. So they're 304, so these are all proper enums. And also, I should be using the proper EV values here. So should we find those? What is a 16? So that would be 0, 1, 0. Key. What it's an ABS, isn't it? ABS underscore. Okay. So ABS. One zero. So X. So I guess it would be hat 0, Y, 17. Perfect. Alright, we've done that properly. So we've got like 306 now. 306, 304 all the way to 308. We're missing 6 though. So that's in hex. So no one knows that. You know, I'm not 50 yet. So we've got to figure that out. What is it? It's 304. So 130. The gamepad button. That ain't right. Oh, maybe it's a key. Wait, what was it again? It was a key for. Wait, we had it there. 304, way too much. Yeah, so after all the keys, you go into button land. Right. Let's see. Button land. So maybe that is right. Oh, it's also the south button. Okay, so that's X. So down, which would have been the X button I pressed, and I press square. So that should probably be east. Right? Let's quickly just check that one. 8. Oh no, sorry, it's west. 4, 5, 6, 7, 8 west. Okay, so this is gonna map up. So where? Okay. Left is west. BTN east. BTN north. Looking good. Then the start button, we haven't tested that out, so should we do those? We're gonna probably comment out if it's, so we're gonna be testing these guys, and we don't want these to get in the way. So I want to comment any ABS code out, whereas ABS is 3, isn't it? So we say if E type not equal to 3, do the print. So now the analogs won't get in the way. Oh, they do. They show a bunch of zeros. Okay. For some reason. What's a zero type? I never looked at that. Syn report. Synchronization report. Okay. Play. Right. So we're testing out start, select. Just test those out. Does this thing have a select? Right, start is a 115 and a select 114. 14 and 15. Sorry, 314, 315. Oh, why is these things moving? Right, they're not moving anymore. Good. So shoulders 10. Okay, so got it. Wait. 15, 14, 10. Right, 10, 11, 14, 15. Good. Got that. 10, 11, 15. So left shoulder. Huh? Yeah, 10, 11. Good. 10, 11. So that's right shoulder. And then 14, 15 for select and start. Select 14, 15 for start. Yes, so that's the share button and the option button because they've gone and done a thing and changed it, you know. So we'll find those enums. So we saw the BTN. What was that one again? What were these numbers? 304. Getting close. So that means they should be quite close to these. So if west is 308, you've got another 4 until you get to 10, right? So Z. So 1, 2, 3. Why was that TL2? Trigger left. Oh, trigger left 2. Right, so 138. So was it? It was 310, wasn't it? Oh. Oh no, it's 308. Sorry, why did I say 4? Okay, so it is right. It's TL. Yeah, it's TL. So trigger left. So trigger left. And then trigger right. Then these 14s. So from 310 to 14 is 4 more. So that's 310. 1, 2, 3, 4. Yes. Oh, select and start. Well, I'm glad that's there. Right, so let's put us in the right place. Select and start. We didn't do the shoulders pressing in, did we? No, the sticks pressing in. Oh, we should have got those. BTN. Select. BTN. Start. Yeah, so we are using X11 and Xinput, but I think we're going to get rid of Xinput too on Linux. And just use evdev directly. So if you use evdev, you can read from the file descriptors. That's what we're doing here, is we're reading from these event node file descriptors in lsdev input. So we're reading from these event files, and we're using udev to find all the keyboards and stuff. You can go back and watch the previous episodes if you're interested of us figuring this stuff out. So you can watch them while you do some squats or something, enjoy that. So they're on the VOD channel. There's a Windows Manager on Zig that does it. Okay, I don't know about that. Maybe. But yeah. Stick in. Yeah, so we've got those ones in there. That's good. So let's get the 2 sticks. So left stick. 17. Is that probably an 18? I can't see what you are. 18. 318. So what do we get to again? 15. Thumb left, thumb right. Excellent. Thumb left, thumb right. So you would hope that all controllers are done this, but I think what might be wrong mostly is these face buttons. You might want to change those. I don't know. I've heard that these could be wrong, basically, so we're doing a mapping file. But it should hopefully be right. But yeah, I think we'll have a proper remapping system on top, maybe. Will you pull this to Wayland as well? Also, what display thing comes out next week for the next? You know, I'm not sure if that last thing's a good comment, because Wayland has not been trying to replace ancient technology from the 1980s, and it's been trying to come out for like the past 10 plus years. But yeah, Wayland is it's a thing we can do. And by removing the x input 2 dependency and just depending directly on the stuff underneath x11 allows us to support Wayland a lot better. So I wouldn't be surprised if we did, by the time we finish this thing, if we did just change it to Wayland only, because the rest of the Linux desktop would have moved to Wayland maybe by then, hopefully, because it's getting very close to the end apparently. Like, I've heard that what people are saying is that the NVIDIA drivers have just fixed a lot of the problems, but I don't know. I don't try this stuff out. So I just know X works good enough for me, so I just keep using X until I know, basically. Right, so I don't know how we're going to figure this next one out. It's going to be quite... Well, okay. So we kind of want to avoid the spam. So you know what, we're just going to try and figure it out. We can hold an analog stick up and map it, I think. Let's try it out. So it's going to be quite spammy. Nothing's pressed right now, so I'm going to hold up on the left stick. Interesting, right. So right and left give us ones for the code. Up and down gives us a 0 for the code on the 3s. So up and down is 0, left and right is 1. Right analog stick is 3 for up and 4. Okay. Okay. So I think that's quite easy to map. There's an ABS. Right, so it's ABS X. That's kind of wrong. Yeah, that's incredibly wrong. Up and down was 0. That's right, we'll roll with that. So up and down. And then this one is Y for some reason. And then the left and right stick is Z. That would be RX, because that was the next enum, that was 4. And then this one is R. No, it was Z, wasn't it? North and south was Z, yes. So positive and negative. So basically, your west is negative, and so is your north. Okay. Now I've got these triggers. The last one. So I'm going to press in R1, R2 rather. So what is that 313 that I see when it gets released? That gets triggered. That 313. We'll look into that. So that's a 5 and that's a 2. Wait, 2? That's not good. Oh, sorry, I did something wrong. That's a 2 and that's a 5. Right, and then a 313. Let's keep an eye on that. 313, let's remember that one. EV key 313, let's remember that. So the problem is I got this wrong. The Z is actually the left one, because that's 2. 3 and 4 are, so it's Y. These are our Ys and these are RXs. And then this is an ABS RZ. Okay, perfect. So that right there is the mapping. So we still haven't got it. We still have to figure out like, what is the biggest value and the smallest value so we can normalize it. Because the way our event system works is we just give you back a normalized float. So whenever you get back a value from the gamepad action value, we give you back a normalized floating point number for everything, including buttons. So if you have pressure sensitive face buttons, or yeah, are these pressure sensitive like they were on the PS2 days? I remember that. They used to be pressure sensitive on the DualShock does not have pressure sensitive face buttons, continuing the trend from DualShock 4. What this means is that classic PS1 games like Metal Gear Solid series on PS2 will never work on PS5. I remember on when I used to play like Gran Turismo or Crash Team Racing on the PlayStation 1 with the X key, and it's pressure sensitive. And then I realized that this was giving us more. I was giving us digital feedback. Seems like moving from 5 to 1 only has about 2 to 3 times speed up in logging. Yeah, Joe Mega, I think I remember Casey Muratori did a remember that ref term thing that kind of like annoyed people on the internet. There's code in here, and there's like a video that he did, I think, where he goes over like some of the tricks he was doing to get Windows to write out to a terminal quicker. Wait, was he doing it? No, but he was writing his own terminal. So maybe this is the other end of it. Maybe actually, maybe this won't help. Yeah, I think Windows Terminal in general was just slow. I think. So I think like this is the other end of the thing, unfortunately. So maybe it won't help actually. X is legacy and will probably be supported in some odd little distros until after Epoch runs out. Yeah, well, you know, X could be here for a while still. We never know. Like people thought we were going to be on Wayland like 8 years ago, but we're still here on X. It's got to be default in the main distros first. Yeah, we're nearly there, I think. It'd be good, we're nearly there. Right, so what was this 313 one? So 139 in hex. So these get triggered as a button for some reason, but we don't want that. Let's run that again. So these triggers, when you release them, they get triggered as a button. But I don't know if that's something we want. So when you press it down, So I want to be super quick and then I'll close it. Right, so I want to go... Yeah, so I'm going to go... So we got a 1 when we came in. That said you've pressed the trigger in. And then the analog of the trigger happened. And then when you released it, it fired another one of those button events. Now that's not going to be useful for us. But it's interesting to see that they do that at least. Just as a... I don't know. Just something... Yes, it fires these two, but that's not going to be useful for us. And it only fires when you first press it down and then when you release it. Sweet. Right, so that's good to know. So now we've got our mapping file. What we can do is we can run over this, and we can just check these bindings and fire the right gamepad action event for this device that we've got, and then that can go up into user space, and the game can then handle it. So Anything else that we're missing? I think that's it. So we should be able to do a nice little for loop. For action 0. So we're going over all the actions, and then we go for our binding table. To do have a user configurable gamepad action to evdev binding evdev binding just in case the drivers, the gamepad drivers are different. Something like that. Can we see the game? There's only some debug rendering. We've just demoed that we can run compute shaders. So we're just down in the engine doing some engine core bits right now. But there is a YouTube video where I show off the GPU system. Here it is. So we've got like 3, we're just demoing the fact that we can run 3 compute shaders. We've got uploading from the GPU, and we can also read back from the GPU as well. And we have the ability to dispatch compute shaders in Vulkan using our custom shader compiler to compile C to SPIR V, and yeah. So we will be getting back and doing some graphics at some point. After we've done this gamepad input and keyboard input and wrapped it all up, we're gonna port it to Windows, then do a user interface for debug UI, and then we'll do some 3D rendering, research and development. That's the plan. That's the plan. What if your program crashes before you flush the last chunk? Wait. I'm going to cache the log files flush in the large chunks. More log lines, yeah, and keep the ASCII escape codes. Right, nice. Yeah, it seems like it'll work. Transport level security library, fantastic. Yeah, I think the TLS is built in. I thought TLS was built into Rust. Didn't they have thread local? Sweet, so we can run over the mappings. So I guess what you want to do is put it into a pointer. Pointer bindings equal default bindings. And now we just have to change this code instead. So we're just going to go over all of these and say, well, if to get yourself a binding, call it B, because it's a very small context. B equals address of bindings, action, and then you just simply say if B code equal E code and B type. Well, it's actually type and then code, isn't it? So we'll copy paste that quick. The order doesn't matter, but it's my OCD. And now the thing is, right, the value has to be, so if that is true, you kind of got to do a bit more of a complex check, where you kind of want to say if B is positive, you now want the check to be greater than or equal to, isn't it? It's weird. So, Ball pass equal this. So the Boolean check is b value, e value, event value greater. If it's positive, it's got to be greater than or equal to 0. And then else it's got to be e value is less than or equal to 0. And if we pass, we got ourselves an event, people. So what we can do now is we can just fire that event. So we've got a lovely, we made this in a past stream we've been preparing. We got a OS internal. We've got a way to queue events, right? So we've got these already. I've done the whole logic for it. So basically passing the input device that has this event, the action and its value as a normalized float value. I was thinking about changing that name maybe to value unorm. Value is an incredibly terrible name. Value unorm. Yep. Let's chase this around. Good idea. Which means in the OS side of things there is a action value. Oh yeah. So why are we in here? Cool. Yeah, so we're gonna just call this guy. It's gonna be super easy. So we'll just say queue this event thing for us, please. Passing the input device ID. Nice. We got an action. Yes, we have. It's called action. And its value for us, please. So we don't know the range of these values, right? So what we want to do is figure out. We want to go over the binding array, and we kind of want to get the min-max of the value that we're looking at. So we can turn it to a normalized float, right? Yeah, but I need to know how it's implemented. Fair play. Well, Joe Omega, I guess you could, if you want to solve that problem that Mean Gene said, you can also have a segfault handler, right? So if the program crashes, you can also just flush your log, right? But then I guess you got to make sure your segfault handler doesn't crash when it flushes the log, right? But yeah, that's what we do for a few things. Is I've got a segfault handler, so if the game were to crash, we'll be able to do stuff like that. So when our game crashes, we print out a stack trace as well, which is handy. That's one of the first things we did. So how do we get a normalized value? This is a good question. So I think there's an IOCTL. This is like some very IOCTL. Right, what is it on Linux? I think we want to see the docs for this. So IOCTL is like this function which allows you to get some metadata around this file descriptor for these special files in the kernel. And there's a whole bunch of stuff in here. It's basically this big. There's a whole bunch of stuff you can get. So there's one around evdev, I think. Where is it? So I want to find the evdev metadata for it. So I think we'll be able to get the min and max values using IOCTL. Right. I just gotta find the docs for it. IOCTL. Right, here you go. ABS. The devices that support a return wrapped info. Right, this is the change log, isn't it? So let's see if we can find where these are defined. Min max. How do we get that? Oh, okay. Features. ABS, Y valve, X. Right, so we have to do this for each one of the things that is in there. So we want to get like a min max. So yeah, I guess we'll do this. Where's the feature? Right. Let's do some things. So we're gonna have to basically set this up. Load of fun. We'll have to store it in the. We'll have. So you probably want to have this binding per controller. But yeah. So you want to get the features min and maximum value. So you use this IOCTL thing to get that. But we want to support more than just ABS, right? We also want to support it for I don't know what else actually. Let's have a look. So there's ABS, the bit, event bits, key, Linux input. This is in. Oh. Yes. So we have to use this to get the min and max values for also the accelerometer. We'll look at that. Hey there, Roger. Roger. Oh, it is. Roger. How you doing? Hi, do you prefer searching in Google and not use ChatGPT? Well, because I'm half millennial, half Gen Z, you see. That's my like I'm just used to using Google, right? And also ChatGPT, like sometimes it can help you, but I don't know. Maybe it might know some stuff about what we're looking at, but I'm not sure. Because the thing is about ChatGPT is it's going to give you one answer, right? Whereas if you look, so ChatGPT is like, I have scanned the internet, and so I'll ask it a question, and it will tell me what it thinks is best, right? But then like, what happens if I know what is best for my project, and there's like 5 different ways of doing it. So I can go and find the 5 different ways with Google, and then I can be like, okay, this one is the best. And yeah, so I know you could probably query more from ChatGPT by asking it if there's different ways. But yeah, I don't know. I couldn't see straight. Yeah, that's the thing as well, is I don't really use Google too much anyway. That's another point. Like, I rarely use Google. I only use it for stuff I don't know. Which is kind of rare most of the time. This is just new territory. No worries, no worries. Half Gen Z, nah, that can't. You're having a kid. Gen Z can't afford that. That's the point. I can barely afford it. uh, Not funded by myself, I'll tell you that. Like we're very fortunate that my wife has a good job as well. Like we both are in like what is probably a decent position in our careers. But yeah, I don't. It's basically impossible if you have like the traditional dad goes out earns all the money type of thing. It's just yeah, I don't know. I honestly don't know how people are surviving right now, especially in the UK. You know, right? So when we initialize the controller, I think what we'll do is we'll have the binding table inside the um. Yeah, we'll stick the binding table inside the gamepad. Um, Stick it down here. So it's a nice little mem copy, Love me a good mem copy. So there's our bindings, plural. So when we boot up, when it gets connected, we're like, oh yeah, we've got ourselves a thingy, a gamepad. Got ourselves a gamepad. This thing should just go somewhere else. Where do I want to chuck this thing? OS Linux. That's like gamepad. evdev default bindings. Extern instead of static. Just drop it in there. Pretty good. Hi, you're writing your own event handler for Gamepad, native OS events. That's correct. Yeah, we're using evdev to read the events, and we're using udev to find all the USBs and when they get connected and disconnected. For normal people, everything is just more expensive, or is more expensive. Meanwhile, British Gas, we're ripping people off and record profits. Yeah. You see, since like COVID happened and people were saying like, I think there's been a little bit of BS going on because some things are not quite adding up. Things are just more expensive, and I think everyone's just trying to get the piece of the pie, and just using COVID as an excuse. I think the war in Ukraine was. I don't know the complexities of it, but I think the gas companies were scared that there was fear that their profits would change because of the war in Ukraine, and I don't know how much it actually changed. But they jacked their prices up. There was something like that going on. But yeah, there's a whole ton of other stuff as well. I just feel like something's just not quite adding up. Bindings. So these default bindings, right? When we attach the gamepad, right? So look at me, I got me a gamepad, right? And then if it's a gamepad, copy the binding over. So we've got a nice little copy element many, copies many elements. It does a mem copy with the nice size of element thing. All for us, no. Wait, we got a size. We got a copy array one. Copy array. That works. So that just does a copy size of, yeah. That'll be fine. Same size arrays. So input device backend bindings. I don't know if that's right anymore. Gamepad bindings. Oh yeah. And voila. So now we just want to find bindings. And then what we're going to do, bindings. So we don't care about the bindings there. We'll let the compiler do that automatically. We've got to do this thing where we get the mins and maxes still. All right, we'll do that. So I think we want to have another lookup table. So it's just going to have a min and a max. So I don't know if I want to call it evdev range. Min max as an S16. Legendary. So you want to copy paste that, and these are the ranges. So we'll just refresh those ranges, right? And of course we've upped this thing now. We'll sort that in a bit. So basically we want to take this IOCTL thing, right? And the default ranges are going to be 0, just 0, 0, because they might not. Well, we'll max it out, I think. And we'll do a clamp. No, not clamp. Yeah, do a clamp and then normalize it, yeah. Right, where's the... So, when we initialize the gamepad... Okay. We want to do a for loop over... So where we've just been, do a for loop over all of the gamepad actions. And then if this action is a ABS... So we get the binding. If if input device backend gamepad bindings, yes, action type, if that is equal to evabs, right, we want to get the min and max ranges for those, right? So we get this features or info, get your ABS info for your ABS values. That'll be, yes, we'll get the bindings. OS Linux binding star b equal address of that. B code. Then the file descriptor, we've got that, don't worry, we just opened it. And then, right, so if we don't get an error, so I guess, IOCTL, what do you return? Yeah, 0 on success. Sorry, I don't know why it took me a while to figure that out. 0 on success. So if that's true, because maybe the file descriptor, right, didn't open properly, maybe you happen to connect it and disconnect it for whatever reason. So if this is true, we're going to say, okay, we'll get the super lovely range thing we've just made. Ranges. action ranges. So we get the action ranges. So I think by default we'll like, you know, let's get it here. And we'll say like range min. Well, you don't want to use the word min because I think that's defined. No, it's fine because that's some. Right, I think that'd be fine. The government printed tons of money, so much fresh money was bound to go something wrong. Yeah, that's true. I know, it's pretty crazy, wasn't it? Like, or greedflation, which is what's going on. Thanks, capitalism. Yeah. It's just cringe. Like, just all the stuff that's gone on. If anyone helps me to find a music genre, please listen to the soundtrack. Wishes to help me find a music genre, please listen to the soundtrack of the game Teleglitch. Thank you in advance. What's this game Telly? Oh, it's published by Paradox Interactive. Fair play. Alright, I'll look into that. After the buffer format in question 2, forgot to clear the buffer. And now it's huge. So we'll default min, I think, at S16 min. Right, and we'll just say, okay, we'll give this maximum bounds because we don't... No, we want to assume by default. So if it's a button, you'll get +1 and -1. Oh, and also if it's negative, you want to flip it as well. So I think we'll do min is 0, max is 1, and we'll just assume it's a button. Yes. Because we'll be using this to normalize it. Okay. Then if this is true, we'll be able to say range min, range max equal ABS info dot minimum. That should be an S32 for some reason. But if you look at the we'll see it in a bit. They're S16s in the actual event. So that's weird. Okay, so now we've got this. We can now actually normalize the data to a floating point number, which would be super nice. So we use input device backend, get the gamepad bindings, right? So we've corrected that now. So if it's equal to the mapping, it will be a pass if positive is negative. Now if it passes, if it's negative, you want to flip the value. You want to say, so you want to get the value S16, so we'll just double check, right? Oh, it's an S32. My mistake. My mistake. So we'll go back and fix that. We did some S16s and a few other places. Oh my days. Oh no, we didn't. Nice. S. Wait, do we want to do a pre? Do we want to do a pre? Yeah, you want to do a pre-clamp. So it's -1 and 1. Yeah, so before we flip it, we want to do a clamp between the min and max. So you want to get the value. So the value, e value, and then if it's that, you want to flip it. But before you flip it, you want to clamp it. So we've got a core clamp between min and max, which comes from the range. So only if you pass do you really care about the range. Right, so we'll get the range out here for the action. And the range will be... And so if you've got multiple maps, you want to fire multiple events, I guess. Right, if they're mapped to the same thing. So range, min, range, max. And then, so clamp it, flip it, and then you normalize it. So to normalize it, you want to divide it by max. So basically f32 value unorm is going to be equal to float32 value divided by float32 range max. Now we don't do range max take min because the negative is a completely different button mapping, right? We're like positive, the positive range and the negative range is a completely different button mapping. So as an example, going up on the D-pad, sorry, on the analog stick, gives us a negative number, I think, and then down gives us a positive number, but it's the same mapping. But we have in our action, sorry, it's the same mapping from an evdev perspective, but up and down is a different mapping from our perspective, basically. Because we allow you to map the up, down, left, and right all on different axes, if you wanted. So value unorm. So there we go. So we should be able to see that now when we plug that in. Just got to correct the back end size. So we've made these even bigger now. We'll do some maths again. Maths. What are you binding? Gamepad. Gamepad buttons from the OS buttons to my buttons. Oh, slowing. Oh, it's slowing down and not crashing. Then you found it was huge. Yeah, so it's kept funny. Yeah. Why is it progressively getting slower? I guess you're assuming min and max are both equal to distances from 0. They probably should be, hopefully, right? Yeah, that would be weird if they're not. That's a good point, though. I'm just going to assume that, I think. Yeah, up should be a positive value, but I think in evdev, at least when we tried it, that up was negative on this thing and down was positive. So I assume it's the same for these. It's really silly. So yeah, we're gonna try it out. So we've got to guess. Well, no, there's no guessing. Working it out. So we've got a C++ is quite fast. First effort tokenizer that recognizes single character symbols, identifiers, and character literals. Goes at about 100 megabytes per second. Nice. Excellent. Yeah, if you're writing C and C++, you're doing, it's going to be, for the most part, quite well. Quite good. Excellent. Oh yeah. So do you need an LR parser? That's the question. Do you need an LR parser if it's 100 megabits a second? Maybe. Um. So we're trying to work out the size of this structure because I changed it again. So it's 20 times 6 for those things here. There's another 4 plus 4 times 6, which is 24. Plus. So this is a size of 2, 4, 6. Right. Because that'll align up to 2. So that's 6 times 6. 36. And then range, so that's aligned to 4, which is that aligned to 4? Yes, that's aligned to 4. Is it? Yeah, it's aligned to 4. So then you go plus 8 times 6. Oh, maths. 48, right? 228. Let's try that. We've still got it wrong. No. We could just do a thing, right? Ugh. Alright, it's too big. Too big, apparently. What about 200? Oh. Come on, that's got to be wrong. Wait, I said if size of is greater than or equal to, didn't I? I didn't say less than. Wait. Yeah. Silly me. So 234. Let's try that. Still got an error. Say 248. Still got an error. So input devices must be less than or equal to the backends. 300. Oh wait, we didn't do times by the button action count, did we? Crap. Right, it's gonna be way bigger than I thought. Because that's like... I just did times 6 instead of times whatever all this big enum is. Okay. We'll find it. So let's do 400. Still going. 500. All the bytes. That's what we want. So let's do 448. Okay. Let's do a binary search, right? So round it to the nearest 4. Ooh, it's getting close. So binary search still. So we're going 72. So go a bit higher. Oh, so it'd be 6. I think that's it. No. What? Should we round it to the nearest? Hmm. Okay. So 80. That's fine. But if I go to 79, it'll crash. Okay, it's 80 then. Got it. Finally. Logging Vulkan info because I'm logging out. Right. Lines per 2 times devices, that's what takes a while. Yeah, still though, it's not a lot. You would hope the console's faster than that, you know? But yeah, Windows. Well, these hard-coded values are and cannot get those sized dynamically. Right. Yeah, so bit of context. So basically, this is internal Linux stuff, right? OS Linux internal. I don't want any of this or any of this X11 garbage being included into any files outside of this. So this is all walled off, right? The outside world doesn't have access to this at all. And if they do, it's via void star pointers or yeah, basically opaque types. So if you want to get this X11 window handle, we give it to you as a void star pointer, and you cast it into something else. Now, so basically, we have this input device, which is specific for Linux. These are the specific bits for Linux for the input device. Then if we go into the OS internal, you see you got the input device here. It's got a special backend thing. So the way we've done it, so this means that the OS implementation file does not know about Linux Windows. Instead, there's an opaque sort of raw bit of data which is aligned specifically to what the backend needs it to be and has the correct size. So we've got some assertions to make sure that this size that we say is on the different platforms is what it actually is. But yeah. So that's all we do. We could allocate the memory though, make it a pointer, but then there's some indirection, and we want to avoid the indirection. So we do it. Yeah. So yeah. So we put these assertions in instead, and that solves the problem. But yeah, the pain point is you have to change it when you change the size, but you can also just do a greater than and then fix that up later. But yeah, pros and cons. Okay, so we've plugged it all in. Let's give it a go. It's not working at all. Is that because we've not got printing happening? Should we look at the main? Do we have a gamepad button at all? No. So let's wire one of these in, shall we? So let's go and get our gamepad actions. Now we're only doing a pressed. Wait, are we doing a pressed? No, we're doing an action updated. Right, let's try this out. So let's give it a go. So they are underneath text input UTF-8. So we should be able to print out, I'm hoping to be able to print out the names. Gamepad, action, pressed. And we'll put the input device in, we'll just do a raw thing, I don't want it to be too big. And should we give you a string representation of the thing? Now I don't know if we've got that. Oh, we do. Passed me to the rescue. We also want to print out a value. So the value is a normalized float. So I think I'll do like a .3f. It's probably good enough. So we want to do like a event gamepad action for the string name. Let me move this. Oh, is it? Is it support? Is it doing that? Yeah, I'll look into that. Right. Right, is that better? Or should it go higher? Sammy. We could. Oh, I don't know where else I can stick it. You know, I could just move my screen and I can tell myself. On the taskbar, excellent. Yeah, I can see it now. This is good. Right. So what we're thinking is. There we go. Thank you so much for that. I didn't realize it was there. Appreciate the that'd be better. Yeah. Yeah, if anyone's got any suggestions on how to improve the stream, please say, because I do not watch it. I am I'm on the other end of the thing, so any tips are appreciated. Game action dot value. Right? Beautiful. So we should be able to do that and then do a nice little released. And hopefully it works. Oh, we're getting a whole bunch of stuff happening. This is really good. So we can test it all out. I do want to... Should we put a dead zone in? That's something that we don't have is a dead zone. Because it's bloody annoying. I'm just getting a bunch of garbage coming through. So... Should we look at that range? Thing. Is there like a... Fuzz flat resolution? What's all this fuzz flat resolution stuff? Specifies the fuzz value used to filter noise from the event stream. That could be the dead zone. Values within this value for flat will be discarded by joydev report as 0 instead. Excellent. So that could be the dead zone flat. Fuzz are discarded. Flat. A resolution is the values reported for this axis. We'll debug out that. But we also want a programmable dead zone, to be honest. And this value is probably not good. Yes, definitely save my sanity. We'll drop an exit here just to have a look what it actually these things are. Right, so flat is 0, not helpful for us anyway. But should we look at fuzz, wouldn't it? Yeah, all right. User programmable dead zone. So let's not worry about it making it user programmable just for a second. Seems like a little bit of, like, we basically want to discard anything. So it won't be in the OS Linux specifics actually. Instead, we want to check to see if the event is an action and then discard the dead zone. Sorry, is an analog. So we just want to know if it is one of these analog things. So we want like a, do you want a dead zone on each? You might want a dead zone on each one of the, each stick. Left stick triggers. But for now, we'll just do a hard dead zone. So we'll just do it on everything. So game action. Perfect. So for now, what we'll do is we'll just say, okay, if value unorm, and also like if the value hasn't changed. So if the value has not changed, we should probably compare it to what was the previous actual value, because we're not storing it, which we should be. Should we look at that? Gamepad value, we're not storing it. So yeah, because we'll clamp it down to 0. So what we want to say is like, if device action values action is equal to value unorm, then what we want to do, maybe we can then we just want to not process it, right? So I guess we'll just say there'll be some dead zone, 0.1 maybe. We'll just clamp it, but we'll need to, and then we need to say, hey, by the way, I use Arch Linux. Unorm. Yeah, this thing is assigned there. Cool. I was in Gamepad. Let's try that out. Okay, so now we've got. Oh, we still got that exit in there, isn't it? Right. Those dead zones, these values are really high. The mapping is not good. The mapping is not good. So to do user configurable dead zone. We'll do this like really soon. We'll put it in the API. It's not too hard. Just format 1800 empty line. Yeah, maybe it was giving it a neutral. I don't know. We can hard code for a specific thing, and that we can do that, can't we? So let's do a left stick X west. So that's to the right. Wait, no, left. So left stick to the left. Well, if event gamepad action do the print. It's still going to do a release though if it hits 0. Yeah. Right, so if this one goes to the left, it's not showing up. Things. So we're only getting east and south. Interesting. So that's part of the problem. We're only getting east and south. So if I put it to the left, it's getting east. And if I do it to the right, it's still getting east as well. So east is getting picked up. So there's something with a mapping, and I didn't kind of see what it was. It's very minor. All right, we'll look into that. Linux. Yeah, it's a PS5 DualSense controller. Yeah, so we just plug it in and we're just reading it. It's provided by the kernel. I don't think east and south are flipped because I tried left and right and only east was showing. I know I did an if, like, no, I tried it for west and west didn't happen, I think. Let's try it again. Right, I've just said west. Yeah, it's not working. Values close to 0.5 no matter where you move. Yeah, that's very weird, isn't it? I don't know if it's getting the min and max right for it. We'll see. Yeah, I really like colors in 2. Colors in terminal 2, but do you disable the color mode, John Mega, if it's not connected to a terminal? Do you have a way to do that? Because that's what I typically do. Because putting it in a log file is not helpful. You have to strip it out, right? There are programs to do that. Right, so let's look at east again. So default mapping is this. West is negative, so it could be this negative code. This is positive code. We'll have a look. So if it's a pass, it's that. Fail is that. Good. Could it be the... Yeah, no, ternary operator is quite high, I think, on the precedence. So you go over all the actions, and it's a pass providing that the action is... Hmm. Right. I don't know the easiest way to fix this. Maybe we should say if east. We'll bring this guy in. If east, I want to see this value. Print value equal D eval-e. I want to see what this looks like. And then I probably also want to disable the main printing for now. Damn it. Right, so... Oh, east is up and down. Okay. So I got the up and down the wrong way round. My mistake. So I thought it was weird the way it mapped, but I was mapping numbers into an enum, and I guess I just got them the wrong way round. Okay. So the thing is when I did these, I was like, Y sounds weird, X sounds weird for these, but I just did it anyway. So I think that'll fix it now. Yeah, good catch, Duff. Thank you, thank you. So let's try that now. Oh, sorry about that. Wait, we did the if east thing. Yeah, so it's only doing east. So we'll try east out, so that is right, isn't it? Move to the right, goes all the way to 1. Move to the middle, goes back to 0.5. All the way down to 0 again. Oh no. What have we done? So what is min? What is min and max? So what have we done? So let's get the east value out here and we'll disable. So east. Okay, so 1. Right, so 0 is not min then. Crap. Oh no. We thought... Isn't that annoying? So right is all on and left is off. So right, the way we've got to do this is different. We have to find a midpoint or something. Right. So we could just assume if it's a stick, it does this, but it could be mapping to anything. Yeah. So I thought it was signed they would do -1 to 1 because they do -1 to 1. They do -1 and +1 for these things, which is weird. These D-pad things. So I guess in our mapping system, we can't just have is positive now. We kind of need like a midpoint, and then you would deduct it by the midpoint, and then you need an is positive. So you get a midpoint, and then you deduct it by, and then you can check if it's positive or not. No, I think you just want to say if it's less than midpoint. Yeah. So you just go S32. Yeah, but you need to know if you're looking at the... Wait, we know the midpoint already. We've got min and max, right? So the answer would be if you calculate so range, so S32 midpoint equal range max take min divided by 2. Okay. So that would be midpoint, midpoint. So then there's no extra stuff we have to do. Hopefully that'll work. So then you clamp it between these two guys. Now if it's not, so you have to modify midpoint, right? So you want to say value minus equal midpoint, and you flip it. And then you normalize it off of max. That's not good, is it? You normalize it off of, like, so now what is that new maximum value? Well, the new maximum value is now max take midpoint, isn't it? So you kind of want like F32 value max. Let's make it a little bit more readable. Range max take midpoint. Cool. Right, let's try that out. So, wait, I've got to enable the if statement again. So we're only checking for east. So that's to the right. So moving this left stick to the right from 0 to 1, back to 0. Fantastic. So now we can start enabling more of the other things, and we've got dead zones now. So let's make sure we've got that all correct. So we've got west to the left, going all the way to 1. Then if we go down, we've got a bit of west and south happening. So we've got a south if we go down, and then we've got a north if we go up. So it's all left stick stuff, which is good, so that's correct. Then we have a right stick west. Yes. And then to the right here is east, down south, and then up is north. So we're getting all that coming through. We've got face button south, face down, NAN, amazing. Sort that out. Got a few NANs. All the buttons are NANs or infinities. Triggers work though. So we've got the right trigger going from 0. Obviously the dead zone should probably be different for these. Left. Shoulder buttons don't work, and clicking these guys in don't work either. Start select. Okay, so all the buttons don't work. We'll sort those out just in a sec. Cool, so we're going to super close. So the question is, why have we got NAN? So the range should be set to something sensible. But we probably didn't divide by 0. So we set ranges to 1 minus 1 by default for buttons, but if it's an analog or something with absolute positioning, we read the min-max values out. So we got a range for the action. We do a 1 take minus 1, which gives you 0 divided by 2. So then that'll be 0 as the midpoint. That's fine. Pass. Clamp it between minus 1 and 1, take away 0. 1 take away 0. Yeah, I think this is all fine. So I want to bring back that thing again. We'll try for face down. See what we get. 0.1 is maybe a bit big of a design for joysticks 2 now. Yeah, well, maybe. I don't know, when you press on the analog sticks, it still moves a bit though. But maybe that's more of a different thing to handle. But yeah, we'll make... I need to make sure I remember it should be different. Different for each stick and trigger. Good. So that's not too hard to add in. We can add it in. It's just we want to get the core of it working first, you know. So, 1. A 1 went in there. So, the 1 went in there. Let's just double check. True for positive, right? So it ignores this garbage. You should be... Let's print out what a midpoint is. Midpoint 1. What am I doing to myself? Should be 0, right? So it's 1 take. Oh my days. 1 take minus 1 is 1. Divide by 2 is 0.5 rounded up, right? So if your midpoint is 0. How does midpoint 0.5? Wait, is this right? Am I doing maths right? We get midpoint 1. So I guess that is true. Midpoint. No, but you'll get a difference of 2. Max, yeah, you'll get a difference of 2. Minus 1 to 1 is a difference of 2. Right. Oh wait, I wasn't thinking right. Right. Yeah, it's 2, isn't it? Yeah, it's 10 o'clock and I am also not good at maths. So this D-pad actually comes through as an ABS, by the way. That comes through as an ABS. So max, min. Yeah, so I think the default should be 0 and 1. The buttons. That'll fix that. Then we can move on to, so these will get fixed now. Right, 0s and 1s. So yeah, what's nice about this is if the user maps, like, it's always this normalized value, even if it's a button or an analog, which, so when you plug that into user code, that should be super nice to work with. Should be cool. So we've got all the buttons working basically, shoulder left, shoulder right, start and select, start. You can press these in. They do show up. There you go, left stick in, right stick. Amazing. We've just not got these D-pads working because they're ABS. They're absolute things. They pretend like they're an analog for some reason. So I'm really interested to see what those are. So we do like D-pad down. So we have a D-pad down. First of all, what is your value? And also, what is your midpoint? I guess we'll start there. Okay, D-pad down. 1 midpoint 1. So yeah, I think it's the same problem, right? It's negative 1 and 1. If I print out the ranges, so I just say like, let's just do a range min. That'll tell us the answer. So midpoint will now be range min. Yeah, minus 1. Okay. So we've got enough information to work with that now. So can't you just print out the whole buffer with a single, right? Oh no, different. Hmm. Uh, so, hmm. So they've got the same problem again, right? -1 for the min. Midpoint is 1. So you need to take away the min again, right? So you've got like, this is the range. Yeah, take away the min divided by 2. That gives you the actual midpoint. So this is the total count. Wait, is that right? Or is it total count? I think the divide goes... No, range min plus. Yeah, range min. That's it. So -1 plus the half count. So the half count will be 1, and it goes to 0, midpoint. Excellent. So obviously the 0 worked fine with that previous thing, but not the new one. Okay, so that should be everything done. So we've got the up, down, left, right. Oh yeah, face buttons, shoulders, analogs, everything. Cool. Wait, south 1. Why does the south become 0? That's my weird thing. Oh yeah, it becomes 0 there because it's to the right. That's fine. It's fine, that's good. That makes sense. Yep. Excellent. So what about, so it gets released when it goes back to the middle. Yeah, so if I flick it, you'll see that there's some pressed and then released on the analog sticks, which is cool. So when it hits 0 again, it gets released. Oh, does it break my joysticks? I don't think it does. So down, 1, up, 0. Right. If I go down to the corners, we get 750, right? Yeah, I don't know if it broke it. I think that's fine. You reckon? East to the right, up north. Oh. Wait, that east's not looking good. Maybe it's the controller. Let's have a think. Oh, it might not be linear. What's going on? That was weird. Something weird was going on. It might be the inputs we're getting from the controller. Hmm. How the fuck can vector pop back be const expression? It's so you can use it in a const expression environment, right? Is that right? Yeah, that's fine. I'll do. Alright, that's good enough. Right, that's super awesome. So what's left to do now on the gamepad front is we want to get accelerometer and gyro plugged in, and I also want to get this touchpad working, right, and coming through and see if it's really different from a mouse in any way. When I read the events back, is it different reading it from evdev? Right, how's that look? And then after we've got the gyro and that plugged in, which shouldn't be too difficult now, we want to actually bring the keyboard and mouse, the raw inputs, directly from evdev like we've been doing. So currently we use X input 2 to get this sort of, it's really hacky, but we get the raw key press, and then we basically get the device node property, then do a lookup, and then we can map that into to a specific keyboard that pressed that key, or specific mouse that pressed that key. Now this is not a good solution because now we can use evdev directly because we've sorted out the user group problem. So yeah, that's pretty decent. I'm happy about that. Awesome. Right. Yeah, I don't know. I should really start updating this. Yeah, so when we've got the Linux stuff done, I'll put it all up onto the repo. Yeah, I kind of apologize to everyone who's wanting to look at this code, but it's been in a very temporary state and I haven't been happy with any of it. Well, I haven't been happy with it as a whole, and it's not, we haven't got the game back up and running again yet. So, I don't know, in future I should probably commit this. When I do these things, I should probably commit it at different stages, but yeah, I'll do that in future. So, yeah, we're getting really close to finishing the input stuff, so that's really nice. Right. So the next stream is on Sunday, 4 p.m. GMT plus 1. Yeah, so for those who don't know, we have a Discord where you come hang out, ask questions, talk about game dev, programming, that sort of stuff. If you want to get access to the code, currently the input code is up on the GitLab, but there's a GitLab. So if you subscribe on Twitch, or if you support via Ko-Fi, which is nicer for me, it's the same price, but it just sends more money my way. You'll be able to get access to the code and download it and see how everything works under the hood. There's videos. If you can't really support via that way, you can check each episode that goes directly up on the VOD channel. No, do not leave. You've streamed enough. What do you mean? Yeah, it's like coming up to 11 now. Hey, Dowsy, how you doing? No problem, man. No problem. But yeah, let's find somebody to raid. I would raid Kanji. Kanji's program C, right? But he's just been streaming himself. I don't know what he's streaming now. I don't know why he uses electricity to just stream himself programming from a distance. It's very strange. Also, Mr. Test, good to see you. Good to see you. Right, let's find someone to raid. Yeah, Kanji used to program C. And I used to quite like his style. It was very unique. I miss those days. There's quite a few people, I guess. There's some Jai people. We can raid those guys. It's quite a sensible thing. I've raided this guy a few times. I'll raid this one. That Goblin's game logic, whatever. We'll get this guy. There's Proton Fig. Right. Who's Proton Fig? Proton. I know C. He is live. Oh, Commodore 64. I remember, I think I read this person before in the past. Good idea. Screw those Jai people. Oh, it is. They're not using enough C. Their problems is the CPPs. Right, okay, that's good. Right, have a good yeah, thank you so much for coming everyone. Have a good start to your weekend. I'll see you all on Sunday, if not next week sometime. We're doing accelerometer next stream, gyro, accelerometer, and keyboard stuff. Right, then we go.